All right, this is problem 22 from problem set 5, and this is a very tricky counting problem and probability problem. And the way I'm going to explain it is pretty much the way that's explained in the answer key. However, there are other ways of doing it, and any other way I approached it really became kind of difficult to ensure that you weren't double counting or undercounting things, arrangements and all that. So that can be pretty tricky. I'm still not satisfied with this way of doing it, even though it makes sense. I feel like there are other ways, but sometimes things break down into numerous cases, and it's like more hassle than it's worth. But my point is, I want to return to this problem and try to do it a different way. But let me do it the way that I think makes sense, and that the way the official answer key has it. So this says a parking lot has 16 spaces in a row. 12 cars arrive, each of which requires one parking space, and their drivers choose their spaces at random from among the available spaces. Auntie M then arrives in her SUV, which requires 2 adjacent spaces. What's the probability she is able to park? So very often in probability, you can kind of leverage the fact that probabilities must add up to 1. So the general approach we're going to have here is that the probability that she is able to park, I'm just going to write she can park, is going to be 1 minus the probability she can't park. And she won't be able to park if there are not 2 adjacent spaces, right? So we need to count, we need to figure out the probability that there are not 2 adjacent spaces. So in the next slide, we'll start talking about how to kind of arrange these cars in such a way that there are not going to be 2 adjacent spaces. So first, let's just note that I'm going to take a kind of a combinatorial approach to probability. In other words, as we noted, 1 minus the probability that she can't park. If we kind of expand this a little bit more, what we basically want to do is figure this out. Now, the denominator here is going to be the total number of ways that the 12 cars can fit into 16 spots. Okay, total number. And the numerator that we're looking for is the number of ways they can park such that there are not 2 adjacent spaces. So this in blue we do know, because there are 16 spots and you're going to choose 12 of them to have cars in them. So this here is going to be 16 choose 12, which happens to be 1820. What we want to find out is this, and this is where we have to think a little bit about how to count the number of ways that they can park their cars such that there are not 2 adjacent spaces. Okay, so let's count. We're going to count here the number of ways 12 cars can park 16 spaces with no 2 adjacent spots. So the key insight here is that think of the 16 spots. Think of the 16 spots as being these. I'm going to actually draw them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, so the last two spaces could be situated like this, such that there's a car in a space, right? And so I'm going to call that like case 1. And then case 2 would be, so I'm going to draw them again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, would be a situation where the end is like this, car, space. Okay, so that's, I should say more about that. What I'm really trying to say is that either this place is occupied, okay, so let's occupied, or it's empty. Okay, the last space is empty. Now let's take the case where the last space is occupied. If the last space is occupied, so remember there's 16 spots. If the last space is occupied, in order to ensure that we don't have two spaces in a row, we have to think of our the four available spaces as not being next to each other. So, for instance, just so I can draw something down, I'm going to put a space here. I'll put a car here, a space here. Sorry, that's not what I meant. I meant a space here, a car here. So that's 2 available spots, 3 and 4, right? There are my 4 spots. Now, those are 4 cars there. Now, I can't move these cars around in a way that would make the spots end up next to each other. So what that means is you want to group that, and that. You want to think of those spots as almost being glued together. In other words, a car and a spot to the left of it. You want to glue those together and think of these as 4 separate objects. So let's call them a different letter. Let's use Y here. So I've got those are 4 objects now, and any way you move those, even amongst each other, you're not going to be able to put 2 spaces next to each other. Now we still have 8 more cars, and the cars are going to go in these remaining 8 spots. 1, 2, 3, 4, 5, 6, 7, 8, right? The 8 cars have to go in those spots. So let's put them there, and I'll use X since we've used Y. So there are my other cars. Okay, so now I've got 8 X's, and I've got 4 Y's. Every arrangement of those 8 X's and those 4 Y's is going to amount in an arrangement where the last space will be a car. So remember, these X's are also, those are cars. Any arrangement of those is going to have there be a car here at the last spot, and we're guaranteed that there's no way to get 2 spaces together. So the number of ways of arranging these 8 X's and the 4 Y's is 12 factorial. 12 factorial. That a little bit. So 12 factorial divided by 4 factorial, 8 factorial. Okay, which ends up being, I believe, so that's the same as 12 choose 4. And just for time here, that's 495. Okay. Now, on the other hand, if the last spot is empty, right, then that means to get our other 3 spots, we would want a situation like this. Let's use red again. Okay, so I've got this this, that. Those are my 4 empty spots. I've got an empty spot here, an empty spot here, and an empty spot here. And then I've got, so let's see, that's a total of 1, 2, 3, 4, 5, 6, 7 spots, which must mean there are 9 other spots here. And those all have to have cars because we need a total of 12 cars. So in this case, you want to think of these things as being grouped together, and these 9 spots as having cars. And then we're arranging these, right? 9 x's. We're arranging the x's and the y's because every arrangement of these 9 x's and these y's is going to amount to us having 4 spaces that are empty that are not next to each other, right? Because no matter where you put one of these blocks, you'll never get it next to this empty space, and you'll never get 2 spaces next to each other. This is the case where the last spot is empty, and we've successfully counted all the ways that that the 4 spots can appear in such a way that they're not next to each other. But 9 x's and 3 y's would amount to the number of ways of arranging those are 12 factorial over 3 factorial, 9 factorial, okay, which is the same as 12 choose 3, and that is 220. So this plus this are the total number of ways 12 cars can park in 16 spaces with no 2 adjacent spots. And if we go back to our overall strategy, on the next page, we'll be able to answer the question. Okay, so remember our goal was that the probability that she can park is going to be 1 minus the probability she can't, which is 1 minus, and we figured out that there are 1,820 ways that that 12 cars can fit into 16 spots. And we've just realized that there are 495 plus 220 ways that those 12 can park such that there are no 2 consecutive spots. No 2 adjacent spots open or empty. And this ends up being, so 495 plus 220 is 715, so this is 1820 over 1820 minus 715 over 1820, and that ends up giving you 1105 divided by 1820, but 1105 divided by 1820 is 17 out of 28. And I believe that answer is E. So we see that the final answer is E. So it's a very tricky combinatorial problem. And basically, the way I showed you, I didn't really have time to kind of delve into it because the video got long anyway, but the reason that's a smart way of doing it is it essentially it cleverly counts all the ways of arranging those 4 spots in a way that doesn't double count. So one of the issues I ran into as I started thinking about this is I noticed I was double counting when I didn't realize I was. But I still want a different way of doing it because I don't think this is the only way. And though it might be the most efficient, I'm sure there are other ways that might be a little bit more maybe enlightening and maybe accessible. So in any case, this was a good problem, a tricky combinatorial problem, and hopefully you enjoyed it.